as well as on participants. I would like to welcome you, sir. And I would like to thank you for, on behalf of your busy schedule, you have accepted our invitation. So thank you, sir. I'm now handing over the session to Rajaganesan, sir. Sir. Hello.
Madam.
And kind information to the participants, all the participants kindly mute your audio as well as the video so that you can able to hear the session clearly. Sir, you can start the session, sir.
Okay. Can you hear me?
Yes, sir.
Yes, sir.
Yeah. So welcome all. Good morning, everybody. Today, the webinar is scheduled to discuss on the topic of future of solar PV technologies and how an energy yield assessment study is being done. So as you know, we are in lockdown, and everyone is thinking what to do next and how it can be, taken to the next step. And this is a problem and situation for each and every industry. If the industry is facing the challenge, it doesn't only affect the industry, it affects the complete supply chain, which is nothing but the employees. So why this impact is very seriously should be addressed by an academic sector is your students are the guys who are going to work in a company, going to work in the industry, and the industry have to observe this kind of people, the talented, skilled people. So in order to address that, we must know how the industry is going to transform, what is the future, and what kind of skills, what kind of knowledge, what kind of exposure is required for a student to enter into this industry. So I'm going to address about how actually the industry is evolved and how it's going to further evolve in the future. What are the scope? What are the opportunity for a student and for any a personal, a professional individual to venture into the solar industry as an employee or as an entrepreneur? And also we are going to discuss about what are the market challenges and what are the mitigation practices to overcome from that problems and all these stuffs. And next we are going to discuss about an energy yield assessment study. This energy yield assessment study is primarily used to estimate how much of energy can be produced from plant. So usually all this energy yield assessment study is primarily to estimate the energy generation from the solar PV module and what are the effective AC power which can be achieved out of the generation. People use thumb rule calculations for the energy yield assessment study by just calculating the DC power and just consider the inverter loss and just calculate the AC. But there are many other parameters which you need to keenly focus on estimating an energy yield assessment study. So today we are going to discuss about that. And this energy yield assessment study can be analyzed or evaluated in different methodologies. One is by working out the general assumptions in an Excel sheet. Another is by using the thumb rule calculations, and third is by using simulation softwares. So by using simulation softwares, you have the flexibility to change the instances, change the variables, and you can get the complete report at the end of the simulation. So which is more flexible actually, but you are limited with the kind of inputs which is being given in the software. But if you go with your own Excel sheet kind of calculation for the energy yield assessment study, which will be even much more customized according to your requirement or according to the parameters you're looking on, There are few softwares which I can name that effectively used in the energy yield assessment study of solar PV generation. The most accurate software in terms of energy yield assessment study is Solar Pro and PV Syst and PV Sol. These are the main three things which has been primarily used. And there are another Polyson is there, and cost analysis you can do very well with the Homer. All these softwares. So today we are going to discuss the part which can be done in the Excel sheet to evaluate the energy yield assessment study. Primarily, it is about considering what are the variables, what are the parameters, what are the factors which actually decides energy yield assessment, energy yield generation of a solar PV plant. Because the plant is not going to generate the power on the first day, the same generation for the next 20 years. There are many things which will influence on the energy output of the plant, and which we are supposed to address, consider those variables in our calculations, consider those assumptions in your calculations to come up with the exact generation estimation. Why this generation estimation is really important? It's really important as because whenever you are working out a business model, you are pumping in investments from a financier or a bank, or you're taking up a loan, or you're taking up an equity, you need to justify on which year I can take my money back, so I can take my returns. So to evaluate, to justify, to give a projection or how in which year I can repay the loan, and which year I can take my money back, which year I will make the profit. These are all actually assumed or taken out of the calculations. I have not inserted the presentation right now. I'm going to insert later. This is a brief introduction I'm just giving to make understand what we are going to see in this webinar. So someone is asking the PPT
Sir,
is not
Rajaganesan,
visible.
sir. Rajaganesan, sir.
Yeah.
Sir, excuse me, sir. We cannot see the PPT what you're sharing, sir.
Now, I have not actually shared the PPT yet. I just giving the brief introduction about the
Okay,
the audience that what they are going to do. Okay. So I'm going to take the Excel sheet from my screen. I'm going to lively do all these things. So you can very well see that there's no presentation for this Excel sheet. So I'm going to take the Excel sheet and do all these things for you.
Okay,
so you can see everything in that. So I request audience to note the parameters, and also I will be sharing the things after this webinar or during this webinar also. But I would like to take a note and pen paper to just note what are the very critical parameters that you should not miss in your energy calculations. So got it, audience? Yeah, and I think Sai Kumar is the moderator, right?
Sir?
You are the moderator, host, right?
Yes, sir. Yes, sir. I have given the permission. You can now share the screen, sir. If you have any Excel sheet, means.
Okay. I'll share it. And by the way, all the audience have joined.
I have muted them, sir. I have muted them.
No. All your registered participants have came, or
yes, sir. Yes, sir. Only registered participants.
No. All have came, or someone is left, or
as such, some 43 is expected, sir. 36 have come, sir.
Okay. Why? Because shall we go with to the technical things, or maybe another 5 minutes?
We can go, sir.
Okay. All right. So I'll be first. I'm going to discuss about the energy scenario future, and next we will come to the energy yield assessment practice. 1 minute, I'm taking the presentation to show you. I'm online. So I'll share my screen to you. So audience, can you able to see this? Hello?
Yes, sir. You can see, sir.
Yeah. So we just go into about the basic of solar and its kind of share in India. So you can see the considerable increase of renewable energy in our Indian energy scenario perspective, and these are all numbers, so nothing to discuss with this. So I can share this PPT at the end of the presentation. So you can see the kind of growth in the installed capacity of solar in India. So from 2008, from the Jawaharlal Nehru National Solar Mission on the first phase till 2015-16, the first phase is end, and from 16 onwards till 2020, and the second phase is going. And our target by 2022 is to reach 100 gigawatt. Actually, the 100 gigawatt of solar energy target is being divided into three sectors. One is the 20 gigawatt through entrepreneurs and then through small projects, and 40 gigawatt is through rooftop solar projects, and another 40 gigawatt is through utility scale projects. So what is true entrepreneurs is the the young budding people starting in companies, starting startups, doing small installations in the rooftop, off-grid systems, solar water pumping systems. All this comes under the entrepreneur scheme. The rooftop scheme is primarily to install solar panels on the roof of an big institutes and a commercial complex or a industry, or even for the large household house installations. So these are all coming under the rooftop solar target, and the utility scale actually denotes the kind of installation in a megawatt scale plants where the solar has been installed in acres of land. Like the best example I can point out is uh, the 640 megawatt plant in Kabudi, Ramanathapuram, which has been installed by Adani. So that is one of the largest plant by the time when it has been commissioned in the entire world. So we as a state, as a Tamil Nadu, we are rich in renewable energy generation, but the biggest bottleneck is the kind of absorption of the renewable energy thing into our grid and how we are effectively managing it. And third is the kind of pulling the investments to the market. So this is the kind of targets by 2022 of each and every states in India. So Tamil Nadu is having the fourth largest target of rooftop installations. So these are all the challenges of different kind of solar projects and how to address it. So basically, the supply gap reduction has been happening. Energy security is improved. T&D loss is majorly reduced because of going for solar, and investments comes in. and infrastructure will also improve for a developing country. So these are the positive impacts of solar PV projects coming into the market. So this is the energy scenario of India, which is growing, which is on the higher growth rate, and these are the very key drivers of a solar PV market globally. So why we are going to solar, why we are looking for solar is increasing awareness of climate change hazards, and we need to secure our energy, and rapid decline in the solar energy cost is actually improving it, and high reliable operation. And we have flexible metering mechanisms like feed-in tariff, net metering tariff, and net feed-in, which recently came in Tamil Nadu. So anyone who install the plants have the flexibility to either use the power in their home, or if any excess is needed, it can be exported to the grid, or you use something for yourself and you can export your surplus to the grid, and that can be adjusted in your electricity bill. Previously, it was in the form of only the energy units. Now, government is considering only the cost for the energy, but not the units. So the benefit is, reduced significantly, but still, solar is one of the best investment operation to go with solar tariff. So the main people who will look for the kind of solar installation is a guy who has more tail load. For example, a college institution is having a load from morning to evening, which can be effectively, substituted with solar. So this is the kind of different kind of rooftops which can be installed with solar panels. You can see, and someone is writing on the screen. If anything want to convey. Okay, so I think audience are from different backgrounds, or maybe some people know the fundamentals of uh, solar already, but few people may not be aware of it. The main things which involved in the solar PV system. So I just want to give a brief introduction. So what are the main components of a solar PV system? So one is the PV array, which is very important, which is nothing but the group of solar PV modules. It can be connected in series or a set of series in parallel to improve the current. The next is the grid connected inverter. This grid connected inverter is basically uh, converts the DC from the solar array to AC. And next is the array mounting structure, which used to install the solar panels on the roof. And balance of system is nothing but the kind of systems except inverter and solar panels. What are all the things which is being used or called as BOS, which is I think which is called as balance of system. The next is the transformer, which is used for a large rooftop system to evacuate your generated power to the grid. So this is a typical schematic layout of a rooftop system, where you can see this is your solar panels, and the solar panel have a DC output, positive and negative. This all will be come to the junction box. This is a DC junction box. We used to call it a DC-DB, DC distribution box. Inside we have protection equipments like a DC fuse, a DC diode, a DC surge production device, and a DC breaker is there inside the box. And from that, you come to an isolator, and it goes to an inverter, which convert DC to AC, and finally the AC will come to your energy meter, and from that it will go to the grid. So this is the basic schematic and general working principle of it. And this is a type of PV module which is available. This is a mono, poly, amorphous, cadmium telluride, CHES, and this is a kind of technology comparison, efficiency, and typical area required. As of now in the market, most available product and used product is a polycrystalline for the state like Tamil Nadu. Monocrystalline is also equally coming up in the market because of the higher efficiency, but mono is slightly costly than poly, but still poly has the biggest market in Indian market. But mono is slowly taking it up praise, because the important factor which differentiates poly and mono is the temperature coefficient. See, now mono is having the higher capacity to withstand to higher temperature. So it's a win-win situation, so that the mono will also be equally competing with poly in the future. So these are the different quality standards of PV array. This is a grid connected inverter and its operation. This is the classification of grid connected inverter. You can see a grid connected inverter is primarily classified on the basis of array or basis of transformer. If a transformer is used, it is an isolated transformer. If it's not used, it's a non-isolated. In terms of array, if you classify, it can be classified in 4 ways. There is a micro, string, multi-string, and central inverter. Yeah, so this is the micro inverter. You can see micro inverter from the name itself is a small. So each module is connected to an individual inverter, and all output of AC outputs of the micro inverters are clubbed together to connect to the grid. So the advantages is given, but the cost wise it's slightly high. This is a string inverter. String inverter means you can connect the modules in series, and that is connected to the string. Basically, in a string inverter, only one string is connected. This is a multi-string inverter. Multi-string inverter means you have different MPPTs. So the first MPPT will take care of one string, and another MPPT will take care of another string. MPPT is nothing but maximum power point tracking. So the specification is given here. The central inverter is something like all the modules are having a kind of series parallel combination, and finally it's all connected to one single inverter in a larger capacity. That is called as central inverter. So what are the aspects which has to be considered in an installation is given here. So of course you can, I'm just sharing this presentation to give a brief introduction to the audience, because if I want to discuss about the future, they must know what is actually there in the present. So these are the key components which is involved in the DC cables, AC cables, array junction box, disconnections, protections, energy meters, monitors, and all these things. The array junction boxes, power current protections, disconnection devices, plugs, sockets, connectors, lighting protection systems, earthing, energy meters, system monitoring. The system monitoring has have a very important role in the future solar PV industry. Why? Because in future everything is going to be systemized and accounted. You must have an accountability for anything which is being used in the industry. Earlier days, the cost of a remote monitoring equipment which is supposed to be connected with the inverter is somewhere around 60,000 rupees. But now in a market in a single kilowatt, 1 to 3 kilowatt, the remote monitoring device coming as an inbuilt option of an inverter with no extra cost. So people will be aware of what is my plant is actually generating today. So they are very well aware that my plant have generated this much of energy today, and what is the DC generation happen, what is the AC generation happen, what is the efficiency, and why my plant is not performing good, and all the parameters, all the reasons have been addressed in that. And any fault happen in the inverter, any grid failure happened, any changes in the grid, everything will be created as a log, and it will be sent to the installer who installs the plant, as well as to the owner who is owning the plant, and also to the manufacturer of inverter if it needs to be addressed. So the people who is going to concentrate on the data logging, monitoring, and troubleshooting remotely for the solar plants have a very big future in this industry. And basically it's a kind of an IoT. You need to make everything to be compressed in a hand, and it's a mobile controllable, or at least a mobile accessible. There has a big future. The marking and signages, safety precautions to be handled during the installation of solar. And energy generation estimation will come later. First I will go to Yeah, future. So solar is actually primarily classified into photovoltaics and thermal. Both photovoltaic and thermal has four main domains which has a big feature scope. One is the manufacturing, and second is the material design, and third is according to the applications and how it has been implemented, and fourth is the training and research. These four domains are the very positive and a very more focused domains which has a big feature in the solar PV field. So in terms of PV module, if you take primarily there are two things. One is a module level and is a building integrated photovoltaic. Building integrated photovoltaic is going to be a big thing in the future. Why? Because all the buildings nowadays the green building concept has been widely used, widely practiced, and according to the uh, energy code, green building energy code, ECBC Act, all the buildings which is more than 2,500 square feet for the commercial purpose which is being constructed should have some kind of green energy measures, and solar is one of the important factor which is being mandated in that. So people will be architects, people
Sir,
will be primarily, yeah.
sir, Rajaganesan, sir.
Yes, yes, yes.
Just one small announcement, sir. So
Yeah.
all the participants, they have to again log in with the same meeting ID what they are being given, because the session is going that 40 minutes time limit is there. Now just 1 minute is there.
Okay.
Again, all the participants have to again rejoin with the same Zoom link ID, so that you can continue with the
Including
session.
me.
Yes, sir. Including everyone, sir.
Okay. Okay. So I have
Time
to
is
sign
1
out
minute
now.
remaining, sir, because this basic pack just lasts for 40 minutes, sir. Only 1 minute is
Oh,
there. Again, we have to re-log in with the same meeting ID.
same password.
Same. Then you can again
All
share
right.
it,
All
sir.
right.
So
Okay.
kindly
See
all
you.
the staffs again log in with the same meeting ID. Once this it is getting cut by 1 minute, you can again rejoin the same session.